Welcome to Smarter, Safer Robots, the next leap. Today we explore the most recent breakthroughs in robotics research, highlighting key findings from 48 influential papers. Our focus is on intelligent, adaptive, and trustworthy robots, making real-world impact from hospitals to homes. This episode is presented by AI Frontiers, dated November 30th, 2025. In this presentation, a journey will be taken through the latest advances and challenges in robotics. The discussion will uncover dominant research themes shaping the field, dive into 3 seminal papers that are redefining robotics, and examine evolving methodologies as well as future directions. This synthesis draws upon the combined power of artificial intelligence and human expertise to provide a comprehensive guide to the frontiers of robotics. Robotics is defined as the science and engineering of creating perceptive machines. This multidisciplinary field blends artificial intelligence, mechanical engineering, control systems, and sensor technology to enable robots to sense, plan, and act in complex real-world environments. Modern advancements have expanded robotic applications beyond rigid automation to adaptive, interactive systems that impact healthcare, industry, and daily life. Robotics research serves as a bridge between theoretical innovation and practical deployment. The first major research theme centers on learning-based control and data-efficient skill acquisition. Robots must adapt to new tasks and environments with minimal demonstrations. Sham et al.'s EfficientFlow introduces rapid skill learning through symmetry-aware flow matching and acceleration regularization, while H0 by Song et al. Enables knowledge transfer across robots with varying morphologies. This focus on generalization, enhanced by equivariance and symmetry, significantly boosts learning efficiency, allowing robots to acquire complex skills more quickly and flexibly. The second theme highlights the integration of vision, language, and action, known as multimodal learning. This approach bridges perception, linguistic understanding, and control, enabling robots to interpret and execute intricate tasks. Gu et al.'s ManualVLA links textual instructions to robot actions, while Wang et al.'s DigFlow fuses visual and linguistic data for enhanced planning. Multimodal models empower robots to reason about complex scenarios and respond intuitively, creating more versatile and user-friendly machines. A key challenge in robotics is bridging the gap between simulated training and real-world deployment, known as the simulation-to-reality, or sim-to-real gap. Effective sim-to-real transfer is essential for practical robotics. Wang et al. Address dexterous manipulation in imperfect simulations, while Zhang et al. Demonstrate pixel-to-action policy transfer for humanoid robots. Techniques such as domain randomization and synthetic data generation are crucial for improving reliability. These advances yield robust controllers, allowing skills learned in virtual environments to translate seamlessly to physical robots. The fourth research theme focuses on safety, robustness, failure detection, and benchmarking. Guardian by Picard et al. Generates diverse and realistic failure scenarios to enhance robot safety. NeuroHJR by Li et al. Predicts and explains potential failures in robotic systems. Tools like iGen from Kumar et al. And AGRIL-IRA4D by Patel et al. Establish new benchmarks, while standardized metrics facilitate fair algorithm comparisons. These efforts promote transparency, drive real-world adoption, and ensure that progress in robotics is both measurable and trustworthy. Critical insights from the latest research reveal several key trends. Data-efficient learning methods are reducing training time and cost, making robotics more practical and accessible. Multimodal reasoning, inspired by human chain-of-thought processes, enables robots to decompose and solve complex tasks. Advances in simulation technology are narrowing the gap to real-world deployment, while safety-focused methodologies foster greater trust and reliability. Furthermore, open benchmarks and shared datasets are accelerating collaborative progress across the robotics community. A range of methodologies underpins recent breakthroughs in robotics. Reinforcement learning, often paired with behavior cloning, facilitates skill acquisition through trial and error as well as expert demonstration. Generative models such as flow-based and diffusion policies allow for diverse action representation. Multimodal data. Fusion integrates information from cameras, texts, and various sensors, enhancing environmental understanding. Physics-informed neural networks and control barrier functions ensure adherence to safety constraints, while hierarchical architectures manage complex long-horizon tasks by decomposing them into specialized modules. The first seminal paper is EfficientFlow, Equivariant Flow, Matching for Data and Sampling Efficient Robot Policy Learning, by Chang et al. This work addresses inefficiency in robotic policy learning, combining symmetry-aware flow matching with acceleration regularization. By leveraging equivariance and isotropic Gaussian priors, EfficientFlow achieves high performance with fewer demonstrations. The acceleration regularization introduces a surrogate loss for stable training and rapid inference. This enables real-time, generalizable robot control and marks a significant advance in embodied artificial intelligence. The second highlighted paper is ManualVLA, Chain of Thought Reasoning for Real-World Long-Horizon Robot Manipulation, by Gu et al. ManualVLA unifies planning and action through multimodal manuals that incorporate images, positions, and textual instructions. Synthetic data generated via digital twins enhances training efficiency. This approach significantly increases task success in real-world assembly and object rearrangement, bridging the gap between complex goals and precise robot actions. ManualVLA represents a critical step toward robots that can reason and act in multi-stage tasks as humans do. The third featured paper, Guardian, Vision Language Failure Detection, with Automatic Failure Synthesis for Robotic Manipulation, by Picard et al., advances robot safety and trustworthiness. Guardian synthesizes a diverse array of realistic robot failures by perturbing successful trajectories, creating rich training data in both simulation and reality. Vision language models are then trained to detect and explain failures. The introduction of new benchmarks for safety evaluation further supports rigorous assessment. Guardian sets a new standard for autonomous, reliable robot operation. Looking ahead, several promising directions are emerging in robotics research. Foundation models aim to unify perception, planning, and control within a single architecture. Hybrid multi-agent systems are being developed for collaborative and flexible deployment. Real-world adaptation and continual learning remain ongoing challenges, requiring robots to update skills in dynamic environments. Embedding safety and explainability at every level is increasingly prioritized, while human-centered design and participatory research are shaping how robots integrate into society. These trends will define the coming era of intelligent machines. This synthesis draws upon advanced artificial intelligence tools and human expertise. Text analysis was performed using GPT 4.1 by OpenAI, while DeepGram TTS powered the speech synthesis for summarization. OpenAI's image generation tools provided concept illustrations, and all content was reviewed by human experts for accuracy and clarity. While some oversights may exist, all references have been provided to ensure transparency and reliability throughout this presentation. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thank you for exploring robotics breakthroughs with us. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.